All right, so guys, once again, you need note-taking materials, just pencil paper, but you're not really taking notes. You're just writing down examples of the work that you're going to learn to do. And then guys, you need periodic tables and ion charts, and we'll get rid of phones, and then we'll be ready to go. Or is he asleep? You okay? I'm assuming it's something important, but I had to say it. All right, so guys, what I want to do is I want to reconnect you with what we're doing now, because if you have a really tight grasp of what we are, where we are now, you'll be able to take that and flip it, and you'll be able to engage more successfully in what we're doing today. So guys, today the topic is naming salts. If you're in the habit of organizing your binder effectively, that's the topic. And again, guys, you're really not taking notes, and it's gonna feel like you should. Just trust me, you're not. Guys, all that you need today are examples. So guys, again, what I wanna do is I wanna reconnect you with where we are. If you've missed class or if you're not completely settled with this, if we have high-level questions, we can ask and answer them. But guys, as a little check, if you will, guys, write the formulas for these two salts: nickel 2 nitride and aluminum sulfite. Guys, I specifically chose these two because they will sort of bring out the subtleties and all the little things that you need to be able to keep track of. And obviously I'll do them with you in a minute. And then we're going to use this as a segue into what we're doing today. By the way, guys, too, if you look at this and you're like, I don't know how to do this. Guys, understand you have time, but not a lot. These are certainly skills that you're going to need on Wednesday when we are collecting data and writing up our labs. And then obviously skills for the test. So guys, if you're a little bit stuck, allow me to sort of prime the pump a little bit. So step number 1 is write down the abbreviations for the ions. Then their charges. Then guys, once you have the charges of these ions identified, the next thing that you want to do is figure out how much of each one, how many of each one do you need in order to get the charges to balance. From there, you write the chemical formula. And now guys, we've got this additional layer of parentheses. And so guys, if you need parentheses, well, maybe when do we need parentheses? And the idea is if we need more than one of a polyatomic. So guys, we're going to pick at all those little details as we do these together. So let me give you another second, and then we'll take a look at them. Goldie, are you okay? All right, I'm just looking for people that are still writing. You had enough time. Guys, does anybody else need a second? Are we good? Okay, so guys, literally the process just goes like this. So we know that Ni, oh, come on. We know that Ni is nickel. I think it's element 28 if you didn't know the abbreviation. And then guys, we need the charge. So let's drive this idea home because you were less comfortable with this out of the homework. Guys, what does it tell us that nickel has a Roman numeral? What are we going to find when we look on the periodic table? Multiple charges. So guys, let's go and look at the periodic table. Actually, is it 2, 3, 6 or just 2 and 3? Just 2 and 3. Okay, so, but guys, the beauty of it is we don't really need to go look because the 2 tells us +2 and we just use it. So guys, nickel is +2. Now the next one. Guys, you've probably, because of the last homework assignment, been kind of trained now to look on the polyatomic ion sheet for the negative ion. But guys, notice this one ends in "ide" and it is not hydroxide, cyanide, or peroxide. And guys, that tells us that it is an element, and in this case, it is nitrogen. And then guys, this is the tricky tricky one. Notice I'm pulling out all the little details. Guys, nitrogen is the only negative ion that can have more than one charge. Could be -2, could be -3. Which one do we use? -3. All right. So then, guys, where does 2 and 3 meet up? And we understand that is 6. So we need 2 nickels to be 6. We need, 3 nickels to be 6, 2 nitrogens to be 6. And so, guys, this would be Ni3N2, and that would be nickel 2 nitride. Now, guys, earlier in the day when we were talking about Roman numerals, and guys, I'm not trying to stifle your thoughts, but I did hear somebody when we said, what do the Roman numerals tell us? And somebody, and I'm glad that you said it, said, how many? How many atoms? And guys, understand that's not true. This is nickel 2 nitride, but we have 3 nickels because the 2 tells us the charge and not how many. So, guys, how are we doing on that one? Clarifications? All good? Okay, let's do the next one. So guys, aluminum sulfite. Aluminum is element number 13. It doesn't have a Roman numeral because it's only got 1 charge, and that charge is +3. Then guys, this is sulfite. It ends in ITE, so we know that it's on the polyatomic chart. Guys, be careful, it's sulfite, SO3, and not sulfate, SO4. Common mistake you're going to make is you just find something that begins with sulf and you forget there's an 8 and an ite option. So now, guys, these meet at 6 as well, but the ratio is flipped. So we need 1 or 2 aluminums and we need 3 sulfites. But guys, remember parentheses. Now we need more than 1 of a polyatomic. So if we need 3 of these, we cast it in parentheses and then we add the 3. So guys, if you can do these successfully on your own, you're exactly where you need to be. Notice, guys, we took some time to really step through it, hoping to bring out some of the little details. Bringing out some of the details. But guys, let's just press pause for a second. What questions do you have? Are we okay? Okay. Then guys, this is the new stuff. This is what we are doing today. So guys, what we've done is we have taken the name and we have written the chemical formula. So guys, now what we're going to do is we are going to take the chemical formula and we are going to name this. Now guys, there's only one thing that makes this difficult, and the thing that makes it difficult is Roman numerals. That's why I highlighted it so much throughout what we've done already. Guys, when we write names for chemical formulas, the Roman numerals are the only tricky bit. We're going to talk about it. We're going to do 4, and then you're going to get your homework done. So guys, it goes like this. Hold on, my board's going to freak out. All right, do this. Yep, there it goes. And guys, I really, just trust me, you really do not need to write this stuff down. But it goes like this. Again, guys, the tricky bit about these is Roman numerals. So you need to learn to play the Roman numeral game. And guys, it goes like this. When you are naming these things, the first thing you're going to do is you're going to determine if the cation can have more than 1 charge. Guys, if it only has 1 charge, all you got to do is name the silly thing. Name the cation, name the anion, and you're out the door. But if it can have more than 1 possible charge, you've got to figure out the Roman numeral. And we do this by working it backwards. And guys, it's mathematical. It's a multiplication, an equals step, and then a division. And by doing this, this will allow you to figure out the Roman numeral. So you're going, wait a second, that didn't make sense. Guys, what you've got to understand right now is this. The whole thing that makes this weird is Roman numerals. If it only has 1 possible charge, no Roman numeral, write the name. If it can have more than 1 charge, you got to figure out what the Roman numeral is, and you do that by working it backwards. Guys, we're going to do 4 examples. Strongly encourage you to do this with me. And then, guys, wow, you're going to have an hour, a little bit less, to get your homework done. You guys ready to go? Here we go. So, guys, FeCl3. What is Fe? Find it on the periodic table. It's down in the transition metals, kind of at the top. See it there? Fe is iron. So guys, Cl is obviously chloride. So the question is it okay to write this as iron chloride? Now guys, watch. Let me drive home the point. Is it okay to write this as iron chloride? Well guys, to figure this out, do this. Try to write the chemical formula for iron chloride, the one on the right that I just wrote out. Try to write the chemical formula for iron chloride. Can you do it? Why not? You don't know which charge to use. So guys, it's not okay to call this iron chloride because we don't know which charge. So guys, what we've got to do is we've got to figure out the charge of the iron. So guys, do this with me. Iron chloride, split it in half. This is called working it backwards. Now guys, in order to do this going backwards, you start on the right and not the left. What is the charge of chloride? Find it on your periodic table. -1. So guys, chloride is -1. Now, here's what you're going to do. You're going to multiply, you're going to set it equal, and then you're going to divide. And guys, you don't need to write that out, just to show you the steps. So the first thing we're going to do is multiply. -1 times 3 is -3. So the total negative charge is -3. So if that's true, the total positive charge is +3. Set them equal. Opposite, but equal. And then guys, we got to figure out the charge of iron. So then we go 3 divided by 1 because there's only 1 iron. So 3 divided by 1 is equal to 3. So this would be iron 3 chloride. And guys, it should be written on the same line. I just had to put it up above because it didn't quite fit. But guys, to name this, it is iron 3 chloride. Again, why can't you just call it iron chloride? Because iron can have more than one charge. And as a result, you got to work it backwards, figure out what the Roman numeral is, and include it. What do you think? 3 more to go? Okay, so guys, these get progressively more weird, and so we're going to step through them all just to make sure you know how to handle the weird. So we're going to do this. This could freak out. Yeah, hold on. Oh, my poor board. All right, so gang, the next one that we're going to do, let me do this and this, is Ni3PO42. So guys, discipline yourself to do this. Find nickel on the periodic table and ask yourself this question. Is it 28? Yeah. So guys, find nickel in the periodic table and ask yourself this question. Does it need a Roman numeral? How do we know? More than one charge. So guys, because it can have more than one charge, we've got to figure out what it is. So what we do is we divide this in half. Then work it backwards. So guys, we need the charge of PO4. Where are you going to find that? The polyatomic ion chart. So guys, it's the bottom right-hand column. You see PO, what's his charge? -3. So guys, PO4 is -3. But there's 2 of them. So -3 times 2 is -6. So guys, that means the positive charge is +6. So if the total positive charge is +6 and there's 3 nickels that are creating that charge, what's the charge of each nickel? 2. 6 divided by 3 is 2. So guys, this would be nickel 2 phosphate. Notice not nickel 3. It's not how many, it's the charge. How'd we do there? You okay? And guys, you're always good at asking questions. So I'm assuming, please, Sam. Great question. So where did we find the charge of the PO4? Do you see it now? Yeah, it's over here. Other thoughts? We okay? Okay, two more, and this next one, actually it seems simple, but it does tend to throw people off. So guys, the next one we're gonna do, I've made my board really grumpy. Guys, the next one we're gonna do is Cu2SO4. So guys, again, discipline yourself on this. Find copper in the periodic table. Always do this. Find copper in the periodic table, 29, I think. Does it need a Roman numeral? Yeah, because it can be 1 or 2. And so guys, what we do, again, is we take this, we break it in half, and then guys, be really careful here. What is the charge of SO4? Do you see it there? Let's make sure everyone sees it. Guys, looking on the polyatomic ion chart, in the bottom center column, SO4 is sulfate, and its charge is -2. Now guys, here's where you're gonna muck this up, because you're gonna go -2 times 4 is -8, and that's wrong. So guys, let's be clear about this. SO4 has a -2 charge. How many SO4s do we have? 1. So guys, this is -2 times 1. So this is -2. Pause there. How do we know there's only one SO4? Because it's not in parentheses. So guys, this is -2, this is +2, and then the +2 is divided by 2, right? 2 divided by 2, that is 1. So guys, this would be copper 1 sulfate. Now guys, a lot of times when we do this, I'll have students that are like, wait, if it's a 1, do you have to put it? And the answer is yes. The Roman numeral is never understood. If it's a 1, you got to put the 1. Is now questions? Can we just do one more really quick to make sure you're all okay? Okay, so guys, the last one, and maybe this will actually, yep. So the last one we're gonna do is MgNO3 So we break this in half and we find the NO3 on the periodic or on the ion chart. NO3 is nitrate, which is -1. So -1 times 2 is -2. This is +2. +2 divided by 1 is 2. So this would be magnesium 2 nitrate, like so. Good? Wait, what? Hold on. I see Chase and Benjamin. Help me. What? Okay, so. Did you notice how I did the entire thing facing the board rather than you? Guys, understand we tend to get in rhythms, and when we get into rhythms, we stop thinking. And in a lot of instances, that's good. But guys, some of you caught, some of you didn't, the mistake that I purposefully made to drive home the point. And so maybe you hear Chase, maybe you hear Benjamin, maybe Max talking about this. But guys, this is unnecessary. If you look at magnesium, element 12 on the periodic table, guys, magnesium can only be +2. So what we did is verified something the periodic table had already told us. And that's not just additional work, it's wrong. And so guys, to avoid the mistake, look up the positive ion first, and if it only has one charge, just name it. Magnesium nitrate. Oh, my T didn't get crossed. But guys, you just name it. So if magnesium can only have one charge, this is magnesium, this is nitrate, and you're done. That's all you got to do. Okay, so guys, how are we doing? Good? Grab your homework packets. We're done. Told you this was going to be fast. So guys, we're still on assignment 2-3. Still on assignment 2-3. But guys, we're going to do the right-hand column now, where you're given the formulas and you're writing the names. I'm just reading through these. to make sure if we do the odds, we're not missing anything. Yeah, I think well, there's a lot of ammoniums in there. You know what, guys? Let's really stir the pot. Let's do the evens. So guys, let's do the evens on assignment number 3. Guys, I really suspect that you'll get done. If that's the case, just find something else to work on. And that's going to be our day. The answers are posted on the wall. They're also posted online. Yeah. Let me come and look with you. Guys, by the way, too, don't forget to look up the solubilities of the ones that we're doing, because we are going to need to have that skill available when we get into lab next time. So, guys, we'll do the evens. Happy to help. Go get them.